All right. So, welcome everyone. This is a real treat today. Hopefully, you've been enjoying yourself at our virtual MIP event. I've been thankful to be a part of all the breakout sessions, all the valuable things that people have been sharing with us. This is getting to the end of the day, and we're saving the best for last. So, today we have a special guest, teacher and chair for one of these last breakout sessions. We've got Jeremy Ridley, who's a senior mechanical engineer, project manager from Bresslergroup. This is some of the tips, some of the overall principles, things that he has seen time and time again prove to be valuable pieces of insight that all engineers should know, things that he teaches other engineers, things that they're actually going to reuse this again. He's going to talk about that later with some of the information that's being shared. Really thankful to have him, thankful to have all the attendees. I see that I know some of you guys, see the list here. We've got about 34 people here. Really so thankful for the turnout, and hopefully you guys are really gaining a lot of value from this. Without further ado, I'm going to pass it over to Jeremy, and he's going to start his presentation. Before he starts, if you have any questions, I'm going to be monitoring the chat, or questions and answers, both of those. Feel free to do those. We're probably going to have a time for questions at the end, just like the breakout session. So Jeremy, over to you.
Sounds good. I don't know about best for last, but hopefully we can get something close to that.
Yes.
So today we're going to be talking about design for manufacturing. We called it 7 things every designer should know. A lot of these concepts I think are going to be things that you've probably already thought about, you've already done some of them, but I underline no because I think they're things that we need to kind of build into our daily habits and things that need to kind of happen naturally as we're designing parts, making prints, whatever it may be to kind of build up to the manufacturing process. So the plan is give a little bit of a quick intro on myself, on my company Bresslergroup, do an overview of kind of what we're going to talk about, and then we're going to spend the bulk of our time really talking about those 7 different concepts I mentioned, with 10 minutes of Q&A at the end. But Andrew, if there's important time-sensitive questions that pop up in the middle, stop me and I'll try to answer them the best I can.
Okay, awesome.
So Bresslergroup is an insight-driven innovation lab. We're a really technically grounded product development firm. We help companies kind of solve their next generation of challenges, and we really pride ourselves on delivering unique, kind of clever solutions to the different challenges that our clients may have. We've been around for about 50 years. Like I said, we're really technically grounded. So not only do we do a lot of work in the ID space, building out things that look beautiful and work well for users, but we also try to have them really technically advanced things. So one of the things we like to measure ourselves on is the number of patents that we have that came out of Bresslergroup, and we're around 80 people now. We've been growing pretty steadily for the last 10 years or so. We have 7 different disciplines, all kind of working, in theory, in perfect harmony. So we have design strategy that does a lot of the upfront kind of landscape strategic work, user research that comes in, gets really hands-on with users, learns about what their user needs are, and then takes those learnings, passes them on to our interaction team, our industrial design team, our ME and our EE teams. Those 4 teams are kind of the ones doing the core of the development work, in concert with design strategy and user research. And then we've also have kind of a burgeoning software team as well, doing both embedded software design as well as cloud software design. A little bit about me. Like Andrew said, I'm a senior mechanical engineer here at Bresslergroup. I also kind of run our internship program and do a lot of mentoring of younger junior engineers on our team. And that's really where this presentation kind of came out of. We were kind of teaching the same things over and over, these concepts to young engineers, and we thought, why not put it together into kind of one coherent story. So my background is mostly in medical devices, but I've also worked in consumer products, kind of all over the board. The technologies for manufacturing that I'm most common with are injection molding, thermoforming, sheet metal, machining, and casting. So that's kind of where a lot of the examples are going to come from today. But I think the idea here is that these concepts apply to all the different technologies. So a little bit of overview. I wanted to start with a definition of what DFM is and kind of break that down a little bit. You know, I think a lot of people think about DFM as making parts as cheaply as possible, but I personally think it's more important to make them efficiently than just cheaply. You know, you think of Apple and other companies, you know, they definitely don't do things in the cheapest manner, but they do them efficiently for them. So they're trying to make really high-end products, and they may not use the least expensive process, but they're working to make sure that when they use those processes, they're using them as efficiently as possible. By using DFM best practices, you know, we can prevent quality issues, eliminate waste, and eliminate manufacturing inefficiencies. And the idea is to do that in the product design phase, then putting all of the onus on the manufacturing phase and on the manufacturing team. And like I said, this exists for all different disciplines, and the specific implementation varies widely based on the different manufacturing technologies. So because of that, we're going to kind of take a really macro lens today, not focus on any one technology, just focus on kind of thought processes for that technology. And specifically, I want to focus on things that are happening in the early design phase and the early development phase. Often, you see DFM as part of that green production implementation box there, where we kind of already have our design fleshed out and we're just going to sprinkle some DFM on it, which isn't the right way to approach it. We want to kind of bring DFM and those concepts really early into the process so that they kind of seamlessly lead to a good product. I did include some links in here for some different processes. If there's specific processes questions, we can hit those at the end, but here are some good resources that I've liked kind of throughout my career to guide for more process specific things. So that's the plan. Without further ado, we're just going to kind of jump into the concepts and get rolling. I'm going to move through them pretty fast, but feel free to ask questions as we go through or at the end. So first concept up on the list is sketch early and often. So what do we mean by that? And really the key takeaway here is that visual communication is key no matter what the medium is. And actually I encourage you to kind of expand your thoughts on what sketching means and what the medium for sketching can be. So when I refer to sketching, I'm thinking of any sort of visual communication that can present ideas and concepts or challenges to stakeholders and team members as quickly and easily as possible. So especially early in the design process, we want to do lots of sketching to get feedback from stakeholders without confusion. When you're talking through an idea and you say, oh, it would be like this with a member attached and something attached to the side of that, it's really easy to have two different pictures in your mind and be on completely different pages. So it helps avoid those confusions and get to the answer sooner. You can then use these sketched and rough models to begin getting a good understanding about the number of parts you have, what your best part breakup is, which is going to be very helpful into leading into your best manufacturing processes. So you can develop those early bombs when things are still really fluid and start to break out how those parts are actually going to happen. Sketching also really helps you to define what your CAD model is going to look like before you get into developing your master model, your skeleton model, whatever you want to call it, but whatever is driving your base model. If you have some sketches beforehand, that'll help make that more robust because you won't have to be making major changes to that model really early on. And like I said, I encourage you guys to experiment with different mediums for sketching, and we're going to talk about some of those in the next slide. So the obvious medium to consider for sketching, pen and paper. Here at Bresslergroup, we use that a ton. Our offices are filled with whiteboards when we're there, and people are constantly sketching on there. But we also use a lot of SketchCAD. So this is really early on CAD that we're not really paying attention to the dimensions. We're kind of throwing stuff on the screen, saying it looks about like this, it looks about like this. Really rough CAD just to, again, express those ideas. And then on top of that, we use a lot of drawing. We have tablets in the office, so we do some drawing on our CAD models to quickly express those ideas We use Sketchbook sometimes as well when we just kind of sketch from scratch. But we also, it's nice to have that 3D CAD model, but sometimes that isn't even enough fidelity, and we need to go to like 3D in-person sketching. So we use foam models, we use Legos. I've seen people use clay in the office too. Whatever you need to quickly express your idea to the rest of the team. On to the second concept, starting with the hardest challenges. So, it's really easy to want to start with the things that you know and things that are, kind of easy to knock out. But I encourage you to focus on your primary DFM challenges first. And that has a handful of benefits. Early in the project, your energy is really high, the team's creativity is an all-time high, and communication is also at an all-time high. So that makes it really fertile ground for solving these hard challenges before you get bogged down with 6 months of paperwork and all the other things that go into a project. It's also really nice because there are no what I like to call artificial constraints. These are constraints that are just kind of built up over time because, hey, yeah, we've been showing the model like this for 6 months, and now everyone thinks about it this way. In the beginning, you're really at a blank slate, so it's easy to focus on what your real constraints are and not ones that have kind of developed throughout the project. Starting with these hard challenges also allows engineers and designers to raise the flag really early on these risks and give you more time to solve them. So you can say, hey, we thought this component was going to be easy, but it turns out that it's going to have a 12-week lead time for tooling. We thought it was going to be 6. If you find that out early in the project, maybe that's not a big deal, and you can just plan accordingly for it versus finding it out at the very end of the project. It also helps kind of build more robust CAD models. Kind of going back to what I was saying of before, it gives you an idea of your hardest challenge, so you can start with kind of the core mechanism or whatever it is, and then build out from there so that your casework is based on your hardest part. Now, sometimes the casework is the hardest part, but if you start with the hardest first, then all of the other kind of peripherals are built off of that, and it helps build like a more parametric CAD model. Because when you go up to the tree to make those changes, everything else will delineate down from it. I think another little side benefit here, it helps your team build confidence too. When you've solved the hardest problem and it's all kind of smooth sailing from there, it helps the younger engineers kind of have that confidence that, hey, I've already solved the hardest problem. The rest should be easy from here. A couple of different ways that I recommend figuring out what your hardest design challenge is. The first thing is just to ask, what's the primary function of your device? And a tool we use that I have shown on the right there is called an abstraction ladder. You start with kind of an initial statement that said, so the example that's given there on the right is, to make a better music player. Then you can ask why questions to go kind of up a level of abstraction, and how questions to go down a level of abstraction. And then kind of look at all of your possible questions there, or statements there, and choose the one that you think fits your project best. The other thing that you have to do is look at your must-have requirements. As a part of that, you have to get your requirements written down somewhere so you can look at the ones that are must-have. But then take those must-have requirements and think about where your design is going to be the most constrained and where you have the longest tolerance loop, because those are generally your items that will be the hardest challenge there. The picture on the right, we're showing a breadboard model that we built. So we built this breadboard model to get an understanding of what all the components that were needed to go into this system. And then once we understood all the components, we could take them, package them, because that's our hardest challenge, understanding what components were needed, and then build the casework out from that. So starting with this breadboard model that had some of our hardest challenges allowed us to build out from that kind of base assumptions. Concept number 3, don't be afraid of new processes. Be open to new methods that can save you time, money, or reduce risk. And I really just encourage everyone, and this is something that we look for in all of our engineers when we're going through the hiring process, to be curious about new processes. Technology is kind of ever changing. and it's easy to get kind of lost in that and say, hey, well, we've always done injection molded parts. Why would we do anything different? But keep curious and try to learn about new things as they arise. It is always important to make sure that you're balancing these new processes against the risks that they carry. If there's something that you're less familiar with, it inherently will have more risk, and you need to weigh that and make sure it's appropriate for your process. Along those lines, you always want to choose the most appropriate technology, not just the one that you're familiar with. If you have a hammer, everything looks like a nail, but if a screwdriver would work better, use that instead. It's also important to take a look at the whole product lifestyle and think about how that's going to affect your manufacturing method. At times, it may make sense to start with one manufacturing method in the low quantities when you're first kind of getting off the ground. Maybe you're doing a Kickstarter that is only making 100 units, but you want to be open to new processes as your volumes grow or volumes change. So maybe you'll be up in the millions eventually, and that's the case where you definitely want to use injection molding to save costs over machining 100 parts. And the last thing, we run into this at Bresslergroup every now and then. 3D printing can be a production level process. A lot of people think about it as a prototyping process, and we get some pushback from clients, but there are a lot of really good uses for 3D printing at the production level. Sometimes it's an uphill fight, but one that's worth battling. Concept number 4 is find great partners. So I think this is important because you want to develop relationships with manufacturing partners and build a level of trust and comfort with them, so that you can take advantage of their expertise. Now at Bresslergroup, we don't build very much in-house. It's almost all external suppliers, but I think this works for both external and internal suppliers. By building these long-term relationships and building that comfort level, you really help to streamline the process, especially when you get to that production implementation phase. No project has really ever been derailed by bringing in DFM feedback too early. You get that feedback, and it just makes the whole process flow a lot smoother. And I always recommend to be honest and to get honesty in return. Don't go to a supplier and say, oh, we're making 10 million of these, it's going to be amazing, if you really only expect to make 10,000. Be honest with them, get their honest feedback so that you guys can have that good working relationship back and forth. And this kind of goes back to the last point as well, is when you have confidence in a vendor and they have a new technology, they can propose it to you, and you guys have that shared confidence in each other that will be a good fit or not a good fit. It also helps to build a common language. We work with partners that we've been working with for 10 years. So I can say, hey, remember that project we worked on 2 years ago? We had this really tricky undercut. Could we use a similar tool there? Or, hey, last time we worked on this, it didn't go so great. Here were the challenges that we saw. What can we do to reduce that this time? You kind of build up that common language and like a playbook almost you guys can go back to get things right on the first try, hopefully. Make sure to give clear feedback to the suppliers too. It may be too late to fix something on the current project, but it always helps establish that rapport for the next one. And the last item is to try to be a sponge. This goes along with being curious. Vendors are going to know much more about their process than we as designers could really ever hope to know. So you want to soak up as much as you can from them, so that you can just kind of build your toolbox of knowledge when it gets to designing the next part. Concept number 5, eliminate risk. So I think this is kind of an obvious one that, of course, we want to eliminate risk, but I think that the question here is how do we go about doing that? And what I'm going to advocate for is to kind of take risk in really bite-sized pieces, and weigh the risks of kind of each design and each part of a component, and work to minimize each of them individually. So projects are a constant journey of risk reduction. Really early on, it's very easy to make changes, and the closer we get to launch, the less time you have to make changes and the more costly that those changes are. things are going to happen that are unexpected. So anything you can do early on to really minimize those changes at the end is going to make everyone happy, and it's going to make your life easier. So the first point on that is assume that your parts will not be within tolerance. Obviously, we always want our parts to be in tolerance, but if you kind of challenge yourself to design things that under the assumption that your parts won't be within tolerance or won't be tolerance tightly, you can make a more robust design that will be able to hold up to wear and tear, but also unknowns in the manufacturing processes. What I like to do is ask myself what if questions. When I see a component, I say, okay, what if this component was a half an inch shorter? What happens? What if it was a half inch longer? What happens? And if the answer to one of those sides of the question is catastrophic failure, we need to really take a look at that and say, okay, what can we do so that when we ask those what if questions, both of them are, hey, it's not ideal, but it probably still works. And that kind of helps you find kind of the right dimension for each component. And if you go through that with each component kind of quickly in your mind as you're developing it, you'll end up with a lot more robust design that can handle those changes. Like I said, don't rely on tight tolerances, but also run kind of small little tolerance loops in your head as you're designing these parts. So on the bottom right there, we have shown, a really official tolerance stack up, and I would encourage for any critical dimension to do a in-depth tolerance stack up like this. Save it so you can share it with your team, but be running kind of small little loops in your head for the less critical things as it's kind of coming together, so that then when you are looking to kind of validate your design, you can run these more official in-depth tolerance analysis, but at that point in time you already have confidence that that tolerance analysis is going to make sense and not run into problems there. On to number 6. If it hasn't been tested, it doesn't work. So what I'm getting here is that we have to prototype our parts to figure out if they work. It's great as engineers or designers to sit there and say, hey, this makes sense on the computer, but you really have to prototype them to know how that will work. So you need to have a plan for how parts will be prototyped and how that impacts your final design and your final DFM. So all of our designs must be prototyped, and we need to do a series of prototypes often to build confidence in the design. So it's important to take a step back, look at the prototype or the production level parts, and think about how we'll get there. Your design won't be right on the first or second try, so make sure you give yourself time. I often see as projects get crunched for time and budget that the production phase is right up against the product launch, and kind of the people making the schedules tend to say, hey, yep, okay, it takes 3 weeks to get tooling, so in 4 weeks, we'll be shipping parts. And really that it never happens that way. Even with simple tooled parts or simple sheet metal parts, there are always little things that you find in that production phase. So you really need to give yourself time for those iteration loops, whether that be T1s, T2s, T3s. It would be great if we could always just run through the T1s, but you want to give yourself time, and those end phases are often the ones where the most kind of pressure is put on the team, and it's better to give yourself that time and not need it than the other way around. A way that I like to kind of think about this is called backcasting and forecasting. So when I'm starting and I'm really early on in my design, I'll take kind of a best guess at what I think my production solution is going to be like. Going back to some other concepts, I'll sketch that out and then say, okay, now I know I need a series of prototypes to get me to this point. How do I kind of backcast and take steps back from that final production solution and know that I'm going to be confident that each step is low risk? A lot of people like to think about it from the other way, and I think that has advantages too. But I also recommend approaching it from kind of both directions like this to make sure that you have a very smooth prototyping plan to get to the production phase. And the last one, this is a little bit higher level than some of the other ones, but I think it's something important to remember. and that is to keep in mind first principles. So what I'm saying here is constantly challenge your assumptions and don't create artificial constraints that drive a project. You really want to focus in on those core constraints. So when I think of first principles thinking, what I'm really talking about is breaking down your, the original challenge you're given, your original kind of product spec, whatever that is, into its kind of core assumptions and core first principles constraints is what I guess I'm calling them here. The way you do that is, is by analysis and kind of engineering thinking, for lack of a better word. Once you guys have those constraints and you feel really confident in them, and you're not getting extra constraints thrown on from external effects, then you can kind of use analogical thinking and synthesize those into a new idea or a series of new ideas and solutions. So it's all about being able to deconstruct that core problem to its elements and then kind of building up from the studs there. A couple of comments on that. So don't be afraid to scrap your model and restart with a fresh perspective. It's very tempting when you've spent 2 or 3 weeks on a CAD model and it looks great to say, okay, well, we need to keep building off of this one. We've already spent so much time on it. But sometimes the best solution to get your mind to kind of think about a fresh perspective is just get that blank slate of paper, start from scratch, and build it up from there. First principles are a great tool, but it's also important to keep in that they're kind of complementary with analogy in the design process. If I spend too much time on analysis, I'm really not going to get anywhere. I'm just going to kind of keep spinning my wheels on that analysis side. However, if I use too much kind of analogical thinking, that's going to really distance myself from the challenge. So you need to use them in concert and make sure you're kind of getting the best of both worlds there to get to the best solution. Cool, so I know we kind of blew through those concepts, but quick refresher: sketch early and often, get visual feedback on your ideas early. Start with the hardest challenges, focus on the core of the problem, and solve that early. Don't be afraid of new processes, kind of be ever curious, and leverage your relationship with great partners to learn about those new processes and make sure that you're using the appropriate process. Always eliminate risk. Do what you can to think about your tolerance loops, cut down on any risk in your design. And the best way to eliminate that risk is to build prototypes and keep building prototypes to de-risk at every step. And then remember first principles so you really stay kind of in contact with that core problem. One of my colleagues is doing a similar webinar talking about a lot of these same things and how we can use new technologies to create meaningful innovation. Little slide for it here, but I think with that, we're ready to move on to any questions.
So everyone, you can use the chat functionality. You can use the question and answer functionality. I'm watching both of them. Jeremy, can you go back to your 7th principle while they're doing that?
Yeah.
Okay, so could you give me some practical examples when you say the terms first principle and analogical thinking?
Yeah, so let me start with analogical because I think that one is the one that people use most often and maybe the easiest to understand. Analogical is when I say, okay, I need a hinge that can support 100 pounds. Well, I know the door that's right next to me is about 100 pounds, so I probably can use a hinge that's similar to that to help me create my design. And that's a really fast way of thinking. You know, I didn't have to go and do the FEA on that hinge. Where first principles is, okay, I have 100 pounds. I need this. I need something to rotate my door. How can I do that? Okay, I need it to be roughly this big because I've done the FEA and I know I need this much steel to hold the weight of the door. And it's kind of building up in those little bitty pieces that we know are true constraints and not just assumptions.
Got it. I don't see anybody having questions. We've had more than 50 people joining us today.
Cool.
I am still, we still got, good amount of time. If anybody has questions, looks like it's going pretty well. So any fun project experience for some of the things that you could share as a broad scope on some of the projects you've worked on?
Yeah, let me scroll through the concepts and think if I can come up with some good examples that we've been working on recently. In finding great partners, we recently worked on a device, and let me see if I can pull up some images of it. But it's a swimming wearable called Flex. It's really similar to kind of what you'd see in an Apple Watch, but it mounts to the side of your goggles. And this was a challenge from a couple of standpoints. It's something that had a PCB in it. It had some sensors in it, but we needed it to fit in a really small package and have a good feel for swimmers that are in the water. Swimmers are quite particular about their goggles, quite particular about their whole setup. So we needed to be as least intrusive to that process as possible. And we were fortunate enough to have a couple of different vendors that we could go to and talk about our sealing options. So we considered gluing, we considered ultrasonic welding, we considered overmolding, we considered kind of potting the whole device to just make it a whole waterproof device. And there were 4 different kind of partners that we were experts on each of these things. And because we'd worked with them in the past, we were able to have really in-depth conversations about the positives and negatives. We ended up going the ultrasonic welding route, even though it was a little bit more upfront cost for us, because we had kind of confidence that we could tune in the process and make that process really robust. And then that offered us the best technical solution. So basically the amount of space we needed for ultrasonic welding really cut down on the size of the device and gave it a really good streamlined look on the side of the device.
Fantastic. So one of the questions that have come up, if you also, you can bring up any pictures if you did, but otherwise, what are the analysis most requested by your customers on your designs, and use SolidWorks to basically supply that or integrate that?
Yeah, so we use SolidWorks for most of our analysis types. I would say the most requested from our customers is FEA. So using the kind of like static FEA package.
Static, got it.
Yep. It's a little bit of I'll talk about it from a couple different directions, but static FEA is the most common, followed by thermal. But often we find ourselves using hand calculations first. So open up the old thermo textbooks that I don't really remember from college to figure out those hand calcs. And they do a good job of kind of grounding in the problem and making sure we're in the right direction. Then once we have a good starting point, then we say, okay, now let's get into the SolidWorks module and build up an FEA. And when we can see that the hand calc matches the FEA matches the prototype, then we're super confident that we're in the right realm. We also do a fair amount of kind of fluid flow analysis as a part of our thermal management, because we do a lot of casework design with our electrical engineering team. That's something we're always concerned about and really trying to push the boundaries of how much heat we can get out of the device, and often still have it sealed and working in some of these kind of crazy environments that we tend to work in.
Oh, that's cool. That's cool. With just some of the final things left, what were some of the best projects that you've worked on that, all these things kind of paid off in the end, you're really thankful for?
Yeah. So it ties really closely with, if it hasn't been tested, it doesn't work. We recently worked on a gas mask to help protect first responders and military people. And that's a pretty worthwhile cause. So I think that was part of it. But at the same time, one of the cool things is from the very get-go, we knew how we were going to make this. We knew it was going to be a compression molded mask, followed by some injection molded parts that are kind of stacked together. So that part was really straightforward. The fun challenge was in figuring out how we were going to prototype these things and how to get those prototypes close enough to the production designs that when we went to it, we didn't have any problems. And it was a little bit of an uphill battle to explain to the client why we needed so many prototypes and why they were, a little bit more expensive than they expected. But when we kind of broke it down for them and said, hey, we're going to do more prototypes, but what that means is that when we go to your compression molding tooling, that's like a crazy amount, it was like $500,000 for a tool. We know we're going to be good when we get to that. We're not going to have to make any changes at that point. So it was a pretty long process. I think that was a project that I worked on for about 4 years on different aspects of it. But it was very cool to kind of see that final step and say, oh, see, when we went to production, we were good to go.
That's awesome. So with these principles, is there any flexibility when you're working with different goals in terms of quantity in mind? So you are going for a small batch, or you're going for millions, or just even the tens of thousands?
So I think all of these require balance. If you take any of these to the extreme, you're going to be kind of spinning your wheels. I think that's most obvious with first principles, but I think it's true for all of them. If we are spending too much time sketching and not actually like getting into real nitty-gritty CAD, that's not going to be great for us either. So it's all about balance. I think, it's a good question because I'm not sure I have the full answer, but I think most of these will serve you well, whether you're designing for 10 or for 10,000 or 10 million. I think eliminating risk becomes a little bit less important. If I'm making 10 of them and I'm 3D printing them and it's very easy for me to make 10 more, it's less important for me to kind of mitigate some of those production risks because the cost for my production is so much lower. Where if I'm making 10 million and I'm making a huge investment in tooling, I really need to hone in and eliminate all those risks much more in depth.
Awesome. So are there any stories where these design principles actually ended up with a solution that was very different than what your original thought would be or your logical approach would have created?
Yes, absolutely. And a lot of these are somewhat designed to allow for that. So I think most of them, especially kind of the first three, are about leaving your mind open to solutions that may not be obvious from the get-go. Going back to the swim sensor that I talked about, the client originally came to us asking us to make a set of goggles for them. So they wanted a set of full goggles with this built in on both sides of the goggles. After a little bit of user research, we found that swimmers are very particular about their goggles, like almost to like a religious level, where I have always swam with these types of goggles for my entire life, and those are the only type that I will swim with. So that kind of led us down a path of wanting to not do goggles, but how do we figure out what will work? We did a lot of sketches really early on. We went to some of our partners and found out how small we thought we could actually make this device, which was our hardest challenge. And then we used that to build up more detailed sketches and take those and put those in the hands of the customers. So we were eliminating a risk with the customer from those prototypes to say, hey, would you be comfortable wearing this? I know that you don't usually wear anything under your goggles, but how would something like this work? Okay, what about this? Okay, what about this? And it kind of, to tie it all together, it comes back to remembering that the first principles of our project wasn't to make a set of goggles, it was to make a wearable device that swimmers like. And that was more important than focusing on making goggles.
Great. Okay, final thoughts. Can you go back to the slide that shows the event that you wanted to advertise?
There we go. Yeah,
Okay,
so
great. Yeah, go ahead. Please explain.
to give you a quick rundown on it, one of the things we're working on doing more of at Bresslergroup is driving what we call technical innovation. And this is really kind of the marriage between engineering and really upfront design strategy. So it's the first part is taking a look at what's out there in the world, what trends are happening, and then saying how can we take a look at those trends and design something that will work for us in the future. So our director of engineering is going to be talking about basically how to implement those trends that we spotted using new innovative technology to kind of build a full product that both takes advantage of new technology and then aims to solve those trends.
And that's a two-part series, and so those are about an hour a piece then?
Yep, it's a two-part series. The first part actually happened last week, and then the second part is upcoming on November 12th.
Wonderful, wonderful. I don't see any other further questions. Final thoughts, Jeremy? Anything else that you want to encourage people?
No, I think thanks for taking the time today. If anybody does come up with questions throughout this, feel free to shoot me an email. I think it was on like the second or third slide. I had my work email in there. So if you have questions or kind of want to dive into a really specific technology, I would love to do that. Just
Sure.
shoot me an email and I can do that.
Yeah, if you didn't get that and you're watching, just reach out to us. We can definitely, whether through emailing DP or some of the chats or all the different resources that we have to connect, please feel free to reach out to us. Okay, so we got some congratulations on some great presentations. And next up is going to be the keynote speaker, and that's going to be at 3 p.m. This session is actually going to be done for now. If you want, you can come back to some of the chat rooms and the engineers hangout to talk about some of the fun things that we had going on. There's his contact information. So that's what we have going on today. I'll leave this up. If there's any more chats that come up, we can go, but we have a hard stop in just a couple minutes here. So that's, if you haven't gotten the information, then that is it.
All right.
Oh, you know
Thank
what?
you guys. Yeah.
There's one quick question. Is there a recording of the October 15th session that you had on your slide?
I believe there is a recording. I don't think it's been published yet. I would check. Same thing. If you email DesignPoint, we can talk back and forth, and I can get it to you. If you haven't checked out Bresslergroup's YouTube page, that's where I would expect it to be.
Okay.
I think within a week or so, I'd expect it to be there.
Okay, great. By the way, I would be remiss and maybe even dismissed if I didn't note that you came to us also because of our good friend Jake, who is our engineering manager, welcoming you to come speak on our behalf. We're very thankful for that connection and just the Bressler Group in general as one of our clients, one of our strong connections, and we're really thankful to have you. So I think that is it. And now we are good to finish out. We'll see you guys in the engineers hangout.
Thanks, guys.